On September 9, 1980, the MV Derbyshire disappeared in the Pacific south of Japan. She was a British-built bulk carrier of extraordinary scale, nearly 300 meters long, designed to carry enormous quantities of ore and oil across the world's oceans. But during Typhoon Orchid, that scale became almost meaningless. The sea was generating extreme wave loads as the ship repeatedly plunged into the storm. Then, somewhere in the darkness, the Derbyshire vanished. No distress call, no confirmed final transmission, no survivors. 44 people were lost, 42 crew members and 2 wives traveling aboard the ship. And the strangest part was what investigators did not find. There was no wreck waiting at the surface, no obvious explanation, just an enormous ship and an enormous unanswered question. How does a vessel this large disappear without giving its crew enough time to call for help? At first, the absence of the wreck made the investigation painfully difficult. With the ship gone, investigators had to reconstruct a disaster from weather reports, ship design, witness information, and fragments of evidence recovered from the sea. And without a wreck to examine, theories multiplied. Could the crew have made a fatal mistake? Could the storm simply have overwhelmed the vessel? Could the loss have been an unavoidable consequence of conditions no ship could survive? These explanations mattered enormously, not just because 44 people were dead, but because the Derbyshire belonged to a class of large bulk carriers operating around the world. If the cause was human error, the implications were different from a fundamental weakness in the ship's structure. That distinction would become critical, because eventually the question stopped being what happened to the crew and became something much more uncomfortable. Was the ship itself vulnerable in a place engineers had underestimated? For years, the evidence remained incomplete. Then the wreck was found, and the investigation could finally move from speculation to forensic reconstruction. The breakthrough came from going down to the wreck itself. Deep-sea search operations eventually located the Derbyshire nearly 4 kilometers beneath the Pacific surface. Now investigators could examine what the ocean had preserved. Side-scan sonar revealed the wreck and its surrounding debris field. 3-dimensional imaging and underwater surveys began reconstructing the final condition of the ship piece by piece, and the evidence pointed toward the forward end of the vessel. This was where the investigation became an engineering problem, not a question of whether the storm was violent. It clearly was. The question was how that violence interacted with the ship's geometry. The reopened formal investigation eventually produced detailed computer animations and theoretical sinking sequences, reconstructing how water could enter the forward spaces and progressively destroy the vessel's buoyancy and stability. The critical mechanism was not simply that waves were large. It was that repeated wave impact could impose rapidly changing pressures on structures never meant to behave like rigid walls against an ocean in motion. Imagine the forward hatch cover as a steel plate supported around its edges. Under ordinary conditions, it carries load through its framing and securing system. But during a severe wave impact, pressure rises rapidly across the panel. The cover deflects. Its supports and securing arrangements absorb the resulting forces, and if the applied load exceeds the structural margin, deformation can become failure. The forensic reconstruction identified the forward hatch region as critical. Once water entered the forward cargo spaces, the problem changed completely. This was seawater ingress. Every ton of water entering the bow added mass while simultaneously reducing the buoyancy available to keep that section of the ship above the sea. The bow began to sit lower, and a lower bow encounters the waves differently. As the vessel plunged deeper into the storm, the forward structures were exposed to increasingly severe impacts. Water could reach areas that were never intended to become part of the ship's internal environment. That created a vicious mechanical sequence: wave impact, structural deflection, water ingress, loss of forward buoyancy, deeper immersion, greater wave loading. Once that feedback loop accelerated, the ship's enormous size offered little protection. The issue was not that the entire hull suddenly became weak. It was that a localized failure at the forward end could initiate a progressive loss of buoyancy and stability from which the vessel could no longer recover. And that explains one of the most chilling details of the case. The crew may have had almost no time to understand what was happening before the situation became irreversible. The final significance of the Derbyshire was therefore much larger than one shipwreck. The reopened investigation transformed the wreck into a mechanical lesson for an entire industry. Modern safety standards began treating forward hatch covers and their securing systems with greater attention to the loads that severe seas could actually impose. International requirements were strengthened, including increased design loads for hatch covers, while later guidance specifically warned of the consequences of flooding forward compartments. The lesson was brutally simple. A ship can be enormous. Its hull can be extraordinarily strong. Its engines can be powerful enough to cross oceans. But none of that matters if a localized structural weakness allows the sea to enter the wrong compartment at the wrong moment. The Derbyshire did not disappear because the ocean suddenly became unknowable. It disappeared through a chain of physical events: wave loading, structural response, water ingress, buoyancy loss, and progressive flooding that investigators eventually reconstructed from the wreck itself. And that is what makes the story so haunting. The ship was built to survive the ocean. It was the interaction between the ocean and one vulnerable part of the ship that ultimately determined whether it would survive.